Alrighty guys, so the next question says we need to calculate the boundaries for outliers and identify and classify the lower boundary, upper boundary, and any outliers, okay? So here we're given two data sets, data set 1, data set 2, alright? And we're going to try to observe what would be the lower boundary, the upper boundary, and the outliers for each of those data sets, alright? So this is data set 1, this is data set 2, okay? Alright, so what we're going to do, guys, is that first we need to try to find our boundaries, okay? But to find our boundaries, we need to firstly identify our Q1 and our Q3. So we need to do our Q1, Q3, which will help us to find our IQR. Then you can do 1.5 times your IQR, okay? And then you'll be able to identify your lower boundary or your lower fence and your upper boundary or your upper fence, okay? And then we'll use that to define any outliers, okay? But already you can identify the outliers because the outliers based on our box plot, okay, is anything that's not within our minimum and our maximum. So technically this point right here, which looks like it's at about 25, okay, is an outlier. Here, this point right here, which looks like it's at 100 for data set 1, is also an outlier. Similarly here, this point right here, which looks like about 5, is an outlier. And this point right here, this 100, is possibly an outlier, okay? So again, guys, you can already find the outliers just by looking at the box plot. But you can find the lower and upper boundary. So again, let's go ahead and let's find that lower and upper boundary. So the Q1, so again, when I look at a box plot, this will represent the min, this is the max, this is your Q1, this is your Q2, and this is your Q3, okay? And another name for your Q2 is your median, okay? So this is your minimum, this is your maximum, okay? This is your Q1, this is your Q2 or your median, this is your Q3, okay? So when I look, my Q1 looks approximately like it's in between 40 and 50. So that would be about 45. And the Q3 looks like it's in between 50 and 60. So let's call that 55 approximately, okay? So the IQR will be Q3 minus Q1, which will be 55 minus 45, which is 10. So then we need to do 1.5 times IQR, so 1.5 times 10 will be 15. Yep, 15. Okay? So now we can do our lower boundary. So lower boundary would be your quartile 1 minus 1.5, your IQR, okay? Because your lower boundary is the lower side away from your quartile 1. So it would be 45 minus 15, which would be 30. Okay? So then our upper boundary would be our Q3 plus 1.5 IQR, alright? So again, that would now be 55 plus 15, which is 70. Okay? So again, we see a point right here, which looks like this point is at about 25. That point is below our lower bound, so that means 25 is a negative outlier, okay? So again, we have a negative outlier at 25, okay? Here's another point that's at 100. 100 is above our upper bound. So right here we have a positive outlier. Okay? So we have a positive outlier of 100. Okay? So now let's do data set 2. Okay? So again, we need to identify our quartile 1, quartile 3, IQR, 1.5 times IQR, our lower bound and our upper bound, okay? So when I try to identify the quartile 1 looks like it's at 50, and the quartile 3 looks like it's in between 60 and 80, so about 70, okay? So the quartile 1 would be 50, then the quartile 3 would be 70, IQR would be 70 minus 50, which is 20, 1.5 IQR is 1.5 times 20, which would be 30, and then the lower bound would be 50 minus 30, which is 20, and then our upper bound would be 70 plus 30, which is 100. All right. So Now we're going to identify any outliers. So again, here we have a point at approximately 5. So again, there's a point right here at 5, and that would be a negative outlier, okay? Because again, it's smaller than our lower bound. And then here we have a point at 100, okay? But 100 is our upper bound. So I would not classify that as a positive outlier because it falls exactly at the upper bound, okay? Normally, any point that's outside of that would be an outlier, but in this case, based on our figure, because the upper boundary is similar to what that point is, we're going to consider it not an outlier, all right? But normally it should be, okay? So let's try the next question. So the next question says, we need to use z-score and understand normal distributions and apply the z-score formula. It says the heights of adult males in a certain city are normally distributed. Researchers have collected data from a random sample of 2,000 males and found that their mean height is 175 and their standard deviation is 8, okay? So the reason why I identify those key things is because to calculate z-score, z is equal to the x value that you're trying to evaluate or try to find the corresponding z-score for minus your mean divided by your standard deviation, all right? So again, that's why I try to identify what my mean is and my standard deviation based on the problem given. So the question says, a group of 5 randomly selected males has an average height of 182 centimeters. What is the z-score for the sample mean? Okay, this time we're trying to find the z-score not for the entire population, but for the sample. So when you're trying to find the z-score for the sample, you're going to do z is equal to x value that you're trying to find the corresponding z-score for, minus your mean divided by the standard deviation, but the standard deviation of the sample, which is represented as standard deviation of x, okay? So you're probably wondering, well, how do I calculate the standard deviation of x, okay, when we're only given the standard deviation of the population? How do I calculate for the sample? So what you can do to remember this is that standard deviation of x or the standard deviation of the sample is calculated by doing your old standard deviation divided by the square root of n. So in this case, the old standard deviation was 8 divided by the square root of n, and n represents the number that we sampled, which was 5. So we sampled 5 randomly selected males, okay? And that would be, again, you can write that as a decimal, so 8 divided by the square root of 5 would be 3.577, all right, 8. If I did it to 4 decimal places, okay? So again, now I can just go ahead and substitute. So I'm trying to find for the average corresponding height of 182. So I have 182 minus the mean of 175 divided by my sample standard deviation, which was 3.5778. Okay. So when I subtract this, I will get 7 over 3.5778. which will give me, so 7 divided by this answer will give me 1.96. All right. So again, guys, just like that. So that's for part A. Part B wants us to find what's the probability that a randomly selected male is between 167 and 183. So whenever I'm trying to find, so again, this is a normal distribution. So I can write what that normal distribution looks like. Okay, and it has a mean of 175, standard deviation of 8, okay, and we're trying to find 167 and 183, so the area in between those. So 167 will be here, 183 will be to the right of our mean, okay? So I need to try to find this area right here, so I need to try to utilize my norm CDF. Because again, I'm trying to find the cumulative in between 167 and 183. So I would be doing norm CDF of 167 as our lower bound. All right, so again, this is our lower bound, upper bound, okay? So 183 is our upper bound. The mean was 175. Standard deviation was 8. So again, we're going to use the standard deviation of 8, not 3.5778, right? Mainly because we're not trying to find the probability of that of this area, all right, for the sample, I'm doing it for the entire population. Okay, so I use the standard deviation for the entire population. Okay, so when I plug that into my calculator, okay, so second function vars, norm CDF, so we're doing 167, 183, 175, and 8. And I got 0.6827. Alright, so let's try the next one. So the next one says we need to try to find what height corresponds to the 90th percentile of the male height in this city. Alright, so because I'm trying to find the height that corresponds to the specific percentile or that specific location, that means I need to use inverse norm. Okay, so I need to use inverse norm. So the inverse norm identifies the area first, so I'm trying to find the 90th percentile with a mean of 175 and a standard deviation of 8. Okay, so again, I would do second function vars, inverse norm, and then the area is 0.9, and then 175 is the mean, standard deviation is 8. On the left side would be 185.3. Okay, I rounded it to one decimal place because again, this is talking about corresponding height. All right, so you can be 185.3 centimeters, technical centimeters. Okay, however, you can, I wouldn't write to 2 decimal places or more, mainly because we're talking about height. All right, so let's try the next question. So the next question says, refer to the context of the LSRL problem in the question above or in the question before. If r squared is equal to 0.81, then what is the value of r? So that's pretty easy to find because all you need to do is the square root of r squared. So I do the square root of 0.81 will give me plus or minus 0.9. Okay? So now we're going to go ahead and try to answer the next question. Because again, I use the plus or minus here because when you take the square root of a number, that number could be a positive or a negative because positive 0.9 times positive 0.9 is still 0.81 and negative 0.9 multiplied by negative 0.9 is still 0.81. So that's why we have the plus or minus. So now we need to decipher if our r value, because that's what this is, all right, if it's positive or negative. So to do that, you need to look at the slope, okay? So again, if the slope, all right, based on what I saw here for our question, the slope was, so based on our question, our slope was a negative 2.5 because we were losing 2,500 every single year or per year. So in this case, our slope is a negative, okay? So the slope is negative, okay? And if your slope is negative, that means your r value is less than 0, all right? So in this case, our r value is negative 0.9, all right? So let's go ahead, let's do the next question, all right? So the next part says we need to interpret Pearson's coefficient or correlation coefficient, and Pearson's correlation coefficient is your r value, all right? So that's your r value. The determination is your r squared. So if I'm trying to define or interpret what the r value means, all right, I need to first state what the r value is, which is negative 0.9. And it essentially is telling me that there is a very strong, all right, very strong negative linear, because again it's least squared regression line relationship. All right, between price of a car, of a used car, and age. And age in years. All right. So let's do part D. So part D says interpret the coefficient of determination, which is your r squared. So our r squared value was 0.81, which technically represents a percentage. So this is saying that 81% of variability is seen between the price of a used car and you can write in thousands, and age in years. Okay? So again, guys, that is how I would interpret it. So let's try the next one. So the next one says we need to try to apply basic probability formulas. So it says event x and y are independent of one another. All right. So if probability of x is equal to 0.35 and if probability of x union y is equal to 0.65 or x or y equals 0.65, then what's the probability of x and y or x intersecting y? All right. Round to 4 decimal places. So in this case, guys, we need to first remember what our general probability formulas are, which is the probability of x or y is equal to the probability of x plus probability of y minus the probability of x and y. All right. And we can also try to remember the probability of x and y is equal to the probability of x multiplied by the probability of y. Okay, so essentially this I can use to substitute right here. Okay, so what I'm going to do is that I'm going to repurpose the formula and try to substitute the values there. So again, I would start out with this. So the probability of x union y is equal to the probability of x plus the probability of y minus, and what I'm going to do is that I'm going to substitute the probability of x and y with the probability of x multiplied by the probability of y. You'll see why I did that, okay? Multiplied by the probability of y. So I'm going to go ahead and now substitute. So the probability of x or y is 0.65, okay, is equal to the probability of x, which we got was 0.35. We don't know the probability of y anywhere, so I'm going to leave that the same. And then we know the probability of x, so the probability of x is 0.35. We don't know the probability of y, so I'm going to leave that the same, and then again, they're being multiplied by each other. So here, I'll just multiply these two, okay, and then move this to the other side. So to move the positive 0.35 to the other side, I subtract 0.35 on both sides of the equation. So some algebra right here. This will give me 0.3. Okay, is equal to probability of y minus 0.35 probability of y. Okay, so in this case, guys, what I'm going to do is I'm going to call probability of y x, okay, just so I can try to do it more algebraically. Okay, I could have done that from the beginning. So I'm going to call, say, probability of y is equal to some variable x. I would have 0.3 equal x minus 0.35x, okay? So technically in front of this x is a 1, so I can just go ahead and combine these terms. So 1 minus 0.35 is 0.65. So this would be 0.65x. So then all I need to do now is divide both sides by 0.65, divide by 0.65. And we get that our x is equal to 0.35 divided by 0.65 is 0.35, or no, sorry, 0.3 divided by 0.65 is 0.4615, okay? So what I'm going to do now, guys, is that I'm going to go ahead and just substitute this value back for P of y. So that means the probability of y is the same thing of 0.46154. Okay? So what I'm going to do now is that the question says, what's the probability of x and y? Probability of x and y is probability of x multiplied by the probability of y. We know that the probability of x, all right, was 0.35. So again, we need to calculate the probability of x and y, which would be probability of x, which was 0.35. multiplied by the probability of y, which was 0.46154, and that would give me, so I would just say second function answer multiplied by 0.35, okay, and I got 0.1615, because it says round to 4 decimal places, and that's the result, okay. So let's try the next one, guys. Let's try the next one, okay. So the next one, it wants us to try to do probability applications and explore discrete random variables and tree diagrams. It says a bag contains 5 red, 3 blue, and 2 green marbles. A marble is randomly selected or randomly drawn from the bag. Its color is re-recorded and then it is not replaced. All right, so that's very important. Stating that it's not replaced essentially means that if I take a marble out or if I draw a marble, it will impact the probability of the next marble being drawn. So that means that this is going to be dependent. Okay? So again, this won't be independent, it will be dependent. So a second marble is then drawn. Draw a tree diagram to represent all the possible outcomes of 2 draws. Okay? So this is how I would represent all those possible outcomes. So I'm going to call this first draw. So let's call this first draw. Okay? So what's the probability of drawing, like, for example, a red marble? Well, for me to know that, I need to first figure out how many total marbles do I have. So the total marbles, okay, will be equal to 5 plus 3 plus 2, which is 10 marbles. Okay? So if I have 5 marbles and I have 5 red marbles and there's a total of 10 marbles, if I wanted to select red, I would have the probability of 5 out of 10 marbles. Okay? So what if I wanted to select blue? Well, blue would be 3 out of 10 marbles. And what about green? Well, green would be 2 out of 10 marbles. All right? That's the probability when I pick it the first time. Okay? So now let's try to figure out the probability when we pick it the second time. So here's now the probability when we do it the second time. All right? So the second draw would now evaluate. So again, if the first draw we made, all right, for red marbles, okay, was indeed a red marble, that means that I would now have 1 less red marble. So that means I have now 4 red marbles remaining, because again, I already took 1 out, and then I have a total. So if I took 1 of that red marble out, that means I took 1 away from the total. So that means I have 9 marbles in total remaining. Okay. And then for blue, again, I took 1 red marble away, so that means I didn't impact any blue marbles that I have left. So again, the blue marbles will stay the same, but again, I already took 1 marble away, so that means I have 9 marbles remaining. Okay, and then for green, okay, again, we didn't take any green marbles, so we still have the 2 green marbles, but I did take a marble away, so that means I have 9 marbles remaining. Okay. So what about for blue? So for blue, I took 1 blue away, so that means none of my reds got affected, so I still have how many reds? I still have 5 reds, okay? So I still would have 5 reds, but because I took a marble away, that means I have 9 marbles remaining. I took 1 blue from the 3 that I have, so that means I have 2 blues remaining and 9 marbles in total, all right? Because again, I took a blue away, which is a marble, okay? And then again, I didn't take any green marbles, so I still have my 2 green marbles, but out of a total of 9 now, okay? And then finally, I took a green marble, so that means I still have 5 red marbles, okay, out of 9 things, because again, I took a marble away. I still have 3 blue marbles, okay? But again, I took 1 marble away, so I have 9 remaining. But I did take a green marble, so if I took 1 green marble from my 10, that means I have 1 green marble remaining. Or 1 green marble from my 2, that means I have 1 green marble, but out of 9 items remaining. Alright? So that's how I would draw the tree diagram. Okay? So now let's try to do part B. So part B says, what's the probability that both marbles drawn are red? Okay? So I need to do the probability that both are red. Okay, so using my tree diagram, all right, so the probability that the first time we drew it was red was 5 out of 10. Okay, so I need to know what's the probability that the next time I draw it, it will be red. So I need to try to do an intersection or multiply by the probability that the second one is red, which would be 4 out of 9. Okay, so basically what you're saying when you say both are red, you're saying red and red. All right. So in this case, red and red will be kind of like an AND function, so you multiply, okay? So this would be, I'm just going to cross simplify just to save me some time. So simplify, that'll be limit 2, 1, simplify, 2, so that's 2 out of 9, all right? So again, it says probability, so you might need it as a decimal. So 2 out of 9, all right, is 0.22. All right. So let's try part C. Okay. So I'm going to do part C over here just to use my space effectively. Okay. So part C says, what's the probability that the second marble drawn is blue given that the first marble drawn is red? So here we have more of a condition because again we have a given formula. Alright, it's hard to do a condition when it's dependent because again if we take a marble out it will impact the probability of the next marble being drawn. Alright, so in this case I would say that this question is a little flawed. It's hard for you to try to solve it, okay, but let's just try to solve it just with the information that we have. Okay, so I'm trying to find the probability that given the first marble drawn is red, so I call it the first marble is red, alright, that will make it where the second marble drawn is blue. So the second marble drawn is blue. Alright, so again it says the second marble drawn is blue given the first marble is red. So given the first marble is red, the second marble is blue. Okay, so you should remember what the general format for given is. Alright, so the general format for given is the probability of A given B is equal to the probability of A and B divided by the probability of B. So in this case, this is A, this is B, so I would say the probability of drawing a blue marble and red marble divided by the probability of drawing a red marble. Okay, first. Alright, so in this case, guys, I already have this information. The probability of drawing a red marble first is 5 out of 10. Okay, we also have this already. So the probability of drawing a red marble first. So probability of drawing a blue marble and a red marble first. So again, probability of drawing a red marble first, and then now the second marble is blue would be 3 out of 9. Okay, so I just go ahead and multiply. So I'm going to write it down here. So 3 over 9 divided by 5 out of 10 is the same as multiplying by 10 over 5. 10 over 5 is the same. We can simplify it to be 2. So this would be 3 times 2. Or well, this can simplify 2 to be 1 and 3. So then this would be 2 over 3. Alright, and that would be the result. Okay, so let's do part D. So part D says, what's the probability of drawing one red and one green marble in any order? So I need to do probability of drawing a red and then a green. So say I did the red one first and the second one is green. Okay, so what I would do, guys, is just do my AND. So probability that the first one is red and the second one would be green would be 5 out of 10. That's the first one is red. Second one is green. Will be multiplying by 2 over 9. So simplify. This would be 2, 1. Simplify 1, 1. So that'd be 1 over 9. Okay. So what also I need to find is the probability that the second one is red and the first one is green. Because again, I need to take it the fact that it doesn't matter the order, so I need to know both those probabilities. Okay, so to calculate this, all I need to do is that the second one is red while the first one is green. So probability the first one is green would be 2 out of 10, and then the second one is red would be 5 out of 9. So simplify 1, 5, 1, 1. So this would be 1 out of 9. Okay. So what's the probability that regardless of the order, what both of them would be, all right? So I would just add those probabilities because I'm saying whether I have the first one green or the second one is green. So this would kind of be like an or. So I would say probability that the first one is green and the second one is, or the first one is red, second one is green, or the probability that the second one is red and the first one is green. Okay, so all I would need to do, guys, is just add them because again it's dependent, so that essentially means that the intersection of them would be 0. So I'll just do 1 over 9 plus 1 over 9, which would give me 2 over 9. Okay, and I think 2 over 9 is 0.222. Okay, I should have also converted this right here to a decimal. 2/3 is 0.667. So 667. All right, because it did say what's a probability, and we represent probabilities as decimals. All right, so again, guys, just like that.